vectors 2. And an example is here. The question is, in the figure below, OABC is a trapezium. AB is parallel to OC, and OC is equals to 5AB. D is a point on OC such that OD to DC is equals to 3 to 2. We have our diagram here, the figure O, A, B, and C. Question 1, given that OA is equals to vector P and AB is equals to vector Q, expressed in terms of vector P and Q, Roman 1, OB. OB is from here to here. So we are going to use a long way, OA to AB, which is expressed down here. We are given that from O to A is vector P, and from A to B is vector Q. So you are going to add the two distances, OA plus OB, which is P plus Q. The second Roman, AD. AD, we are going to use root AO, OD. A to O, we are given as vector P, of which this is opposite direction. So we are going to write this as a negative. AO plus OD. AO plus OD. A to O is negative P. OD is 3 over the total, which is 5. It's written here. But we have the total length, which is OC. OC is 5Q. So you multiply the two, and you're going to get 3Q minus Q minus P. Roman 3, we are told to write CB. CB. We're going to use the root CO to OB. C to O is 5Q, but negative since it is a negative, it is an opposite direction. So it is CO plus OB. CO is negative 5Q plus OB, which is P plus Q. OB, you go like this, P plus Q. So your answer is going to be negative 5Q plus P plus Q. You collect the like terms, which is going to be negative 5Q plus Q is equals to negative 4Q plus P. Your answer is going to be P minus 4Q, which is the same as this one. The second question, you're asked lines OB and AD intersect at point X such that AX is equals to KAD and OX is equals to ROB, where K and R as scalars determine the values of K and R. We're going to find AX1, which is given as KAD. We go back to our AD here. We already found the value of AD, which is 3Q minus P. We write it here. So, since K is unknown, we multiply the two. We have the 2AD, P minus Q, 3Q. We multiply by K. That's AX1. We go to AX2, which is equals to AO plus OX. AO plus OX, that's X2. AX2, and in the question we have OX as ROB. So P plus R, OB we have as P plus Q. You're going to multiply by R, which is the unknown. So your answer is going to be P plus PR when you multiply the two plus QR when you multiply the two. Next, you are going to factorize these two. Since P is common, you put it outside, and inside the bracket, you're going to have 1 plus R plus QR. And as you all know, AX1 is equals to AX2. AX1 we have as PK minus 3QK is equals to AX2, which you got P into 1 plus R. You close the brackets plus QR. So you collect the like terms. PK is equals to P into 1 plus R. Here it is. And then you do away with the P, and you'll get K is equals to 1 plus R. That's equation 1. The second one, we have 3QK, negative 3QK is equals to QR. You do away with the Q since it's common. You're going to remain with negative 3K is equals to R. So k, in the first equation we got, k is equals to 1 plus r. Where there is r, you put negative 3k. Since here we wrote negative 3k is equals to r. So where there is r, you replace with negative 3k. K is equals to 1 minus 3k. Since positive plus negative, you get a negative. K is equals to 1 minus 3k. K plus 3k, you collect the like terms, is equals to 1. K plus 3k, you get 4k, is equals to 1. You divide both sides by 4, you get k as a quarter. That will make it easy to get the value of r, which we wrote as r is equals to negative 3k. R is equals to negative 3k. Where there is k, you replace with a quarter and you multiply. You'll get your r as negative 3 and 3 over 4. Therefore, k is equals to negative a quarter and r is equals to negative 3 over 4.